Imagine you're on an operating table surrounded by a team of skilled surgeons. The stakes are high, every movement matters. The overhead surgical light shines brightly, illuminating every detail. But here's something strange. No matter how the surgeon moves, their hand casts no shadow. Why? It's not magic, it's simply science and engineering. Shadows are created by traditional lights because an object in the air stops the beam, but this is very different. A sophisticated array of LEDs is used in surgical lights, each at a slightly different angle. These beams overlapping, shadows disappear, an even, uninterrupted field of light. But there's more. These are not passive. Advanced models can be equipped with real-time sensors that detect an obstruction and turn the brightness on individual LEDs by itself. They dim some, but intensify others, ensuring adequate illumination without dark spots. Think of it as an invisibility cloak, but for shadows. The significance of this technology is allowing surgeons to focus single-mindedly on the work without the risk of overshadowed, minute details during complex procedures. Incandescent and halogen bulbs represented the lighting solutions that operated rooms traditionally used before the advent of the modern LED surgical light. Although these earlier technologies were bright enough, they had major disadvantages, including heat generation and the inevitability of creating shadows when light was interrupted by objects in its path. Surgeons had to move or use extra overhead lights to minimize these problems. Finally, LED technology made the breakthrough. LEDs are considered to be very bright, cool, and with low heat emission. They last longer compared to conventional bulbs and can even have precise controls on brightness and position. The way LEDs give multi-directional outputs assures that no dark, shadowy shadows are developed in the surgical field, since overlapping light beams eliminate shadows. Surgical lights are designed to provide constant illumination without glare or shadows. They achieve this through several mechanisms. Multiple light sources. Using an array of LEDs instead of a single bulb, surgical lights can distribute illumination from different angles, ensuring that shadows are cancelled out. Adjustable intensity. Surgeons can control the brightness levels to suit different procedures and reduce eye strain during long operations. Color temperature control. Some surgical lights allow color temperature adjustments to improve contrast and tissue visibility. Real-time shadow compensation. The most modern systems come with sensors that detect the obstruction and adjust the individual LEDs for uniform lighting. In surgery, precision is everything. The shadows do mask the vision of the surgeon sometimes, which increases the risk of mistakes. Even a tiny miscalculation will cause complications. Every incision, stitch, and placement of a tool is crucial. These lights are usually used by surgeons for longer periods. The heat emitted by older lighting systems is high, resulting in discomfort and fatigue. Modern LED surgical lights emit a low amount of heat, thereby promoting a comfortable environment for work. Let's compare traditional halogen lights with new surgical LED lights across several attributes. Heat generation. Traditional halogen lights generate high heat, whereas new surgical LED lights generate low heat. Lifespan. Traditional halogen lights have a short lifespan of 1,000 to 2,000 hours. In contrast, new surgical LED lights have a long lifespan of 40,000 to 60,000 hours. Energy efficiency. Traditional halogen lights have low energy efficiency, while new surgical LED lights boast high energy efficiency. Shadow elimination. Traditional halogen lights have low shadow elimination, but new surgical LED lights have high shadow elimination. Changeable brightness. Traditional halogen lights offer low changeable brightness, whereas new surgical LED lights offer high changeable brightness. Color temperature adjustment. Traditional halogen lights do not have color temperature adjustment, but new surgical LED lights do. As medical technology advances, the surgical lighting system is expected to evolve further. Some of the innovations on the horizon include the following. Smart lighting systems, AI-powered lights that adapt dynamically to a surgeon's movements to ensure optimal illumination at all times. Augmented reality integration. The integration of AR displays within surgical lights for real-time patient data and 3D imaging during procedures. Wireless and battery-powered systems. Mobility and independence from external power sources are enhanced, especially in emergency and field hospitals. Although the main application of shadowless surgical lights is to improve visibility in operating rooms, the principles are impacting other industries. For instance, automotive manufacturing. Precise lighting in factories allows engineers to inspect components without the interference of shadows. Forensic science crime scene investigators use a similar lighting method to detect evidence that would not be visible when it is situated in dimly lit or shadowed areas. Photography and film production. The entertainment industry applies shadowless lighting for high-definition imaging and cinematography, the science of light and shadows. Only if one understands the nature of shadow formation can the innovation behind the shadowless surgical lights be appreciated. A shadow is formed by an object in the path of a light source, blocking part of the light from reaching the surface. The sharper the light source, the more defined the shadow. If, however, multiple light sources illuminate an object from different angles, their beams overlap and fill in the dark spaces, eliminating shadows. This principle is just like how photographers use soft lighting to soften the contrast of shadows in portraits. They diffuse light using multiple sources or reflectors to an evenly lit subject with no strong contrasts. It is the same principle behind surgical lights, except this is much more precise and accommodative. Surgical lights form a testament of the incredible interfacing of medicine, physics, and engineering. At their best, they eliminate all shadows, helping surgeons to use clarity and accuracy in life and death-forging moments. What a minor improvement upon what was needed once, merely better illumination, has culminated into now being an integrated part of these modern surgical miracles. The next time you look at a bright, shadow-free light source, whether in an operating room or a photography studio, take a moment to appreciate the science behind it. From eliminating shadows to improving visibility, light continues to shape our world in remarkable ways. If you enjoyed this deep dive into